All right, so this is R1 sets. So we're going to, you have the notes, so we're going to look at the examples. So, this book is laid out in a kind of an interesting way. They have some like concept preview questions, which sometimes are like definitions or things like that, are like really like general questions, and then they get into like the actual questions. And so I just try to hit a few of each thing that's important, and then give y'all something to do after that. So number 6 says to identify the set, and it gives us the set 1, 1/3, 1/9, 1/27, and so on. And it wants to know if it is infinite or finite. So, from your notes, what do you think? Infinite. Because it just keeps on going. Let's see, another concept one says let U be the set 1, 2, 3, 4, 5, and A is the set 1, 2, 3. They want us to find A complement, which is the A with the little apostrophe on it. And so let's review quickly. What does the complement mean from your notes? Yep. So anything that is not in A but is in the universal set. So anytime we have a set U, that's our universal set. That's everything that is in there. And so if A has 1, 2, and 3, but the universal has 1 through 5, what numbers are not in A but that are in the universal set? 4 and 5. So it's the set of 4 and 5. And also the squiggly bracket things, I know they can be a pain to write. Just make it look as best as you can. I don't grade on if your set bracket things look right or not. I know they're hard to write. All right, number 10. Find, we have the set 16, 18, 21, and 50. Union, which that U means, with the set of 15, 16, 17, and 18. So union means everything that's in both sets that are being combined. But if there's anything that's repeated, we don't write it twice. We only write it once. So in this case, this one would be the set 15, and we always want to write them in number order. So 15, 16's in both and 18's in both, but we only write it once. So 15, 16, 17, 18, and then over here 21 and 50. So I want to make sure we have everything written down for those. And again, we don't write repeats twice. For the next few, these ones say identify each set as finite or infinite. And then it says to determine whether the number 10 is an element of the set. So basically, is the number 10 in that set? And it may be like such that it has like ... and we have to determine like, is that one of the terms that's like missing out of the set? So 12. We have the set 1, 2, 3, 4, 5, ... 75. So first, is this set finite or infinite? Yep, it is finite because it has a specific start and a specific end. So it is finite. And then is the number 10 in this set? Yes. So like I said, you may not always see it directly, but in that ... we can assume that it's there. And so the way we write that would be that 10, and then it's this little like curvy E like that with like a little line, like it's like a sideways U with a line through it. But that means element of the set. If the set had a name, I would like name it, but it doesn't. So I'm just going to say 10 is an element of the set. All right, this next one is written a little differently than you may have seen before. I don't remember if I addressed this like notation in the notes, so that's why I want to do one like this. 18, we have the set, and it has x, and then it has a bar like this, and then it says x is an even natural number. So what this means is x such that, so this little bar right here means such that. So x such that x is an even natural number. So essentially that's saying this is the set of all even natural numbers is what that means. So what are the natural numbers? Yep. All counting numbers, not negative, and not 0. 0 is not a counting number. So this is even natural numbers. So what is this, a finite or an infinite set? Infinite, because it keeps on going forever. There are unlimited amounts of them. So this is infinite. And would 10 be an element of this set? Yes. Now, if this instead said odd natural numbers, would 10 be in the set? No, because obviously 10 is an even number. Okay, the next one's use set notation and list all the elements of each set. So essentially they start writing a set for you. They'll give you like a ... You need to fill in the ... 24. I have the set 74, 68, 62. I'm just going to leave a space and fill it in there so I don't have to like write the whole thing over again. And all the way down to 38. So I need to figure out what numbers are missing to fill it in. So how do I get from 74 to 68? What did they do? Subtract what? 6. Subtract 6. How did I get from 68 to 62? Subtract 6, so that means, and I always check the first two because sometimes it might be like, you know, you subtract 6 on the first one and then 5 on the second one or something, so you always like check to make sure it's consistent. So we're subtracting 6 the whole way. So if I subtract 6 from 62, what number do I get? 56. I subtract 6 again and I get 50. Subtract 6 again and I get 44, and then subtract 6, and that takes you all the way to 38. So basically on that one, we had to fill in 3 numbers. Now they could give us one that was written kind of like 18. So number 26, it's the set of x such that x is a natural number not greater than 4. So this one, they don't technically give me any numbers, but they give me enough information that I can figure it out. So what natural numbers are not greater than 4? 0. Just 1, 2, and 3. 0 is not a counting number. It would be an integer. So if it said, well, it wouldn't say integers not greater than 4 because you would have to go all the way out to like negative infinity, and that would just be a lot. But we only include 0 if it's like integers or something like that. So this would be the set of 1, 2, and 3. All right, any questions about that at this point? Awesome. All right, 28. We have these ones say to insert basically the little e that I was making up here for element of. If it's not an element of, we put a slash through it. So basically we're saying that it is an element or it's not an element. Those are our 2 options for these ones. And we're filling in the blank. So they give us 9, a blank that we're going to fill in, and then they give us the set 2, 3, 5, 9, and 8. It's annoying they didn't write them in order. And we want to know if 9 is an element of that set or not. So what do you think? Yes, they write it in for you. So that one is an element. $34. The set of 5 blank. The set of 3, 4, 5, 6, 7. What about this one? Is the set of 5 an element of the set of 3, 4, 5, 6, 7? Correct. It is not, because the set of 5 is not in that set. If that were to be the case, we would have to rewrite this as the set of 3 for the set of 5, and then 6, 7 if it was going to be an element of, but it is not. So normally I trick people with that one, so good job. Okay. Now we're doing true false. So essentially it's like this, but they're going to give it to you like already filled in, and you just need to say true or false that it is or is not an accurate statement. Which is one of the few times we actually do true false in math, because when else are you going to do it? So 42, they tell us that 12 is an element of the set 18, 17, 15, 13, and 12. Is that true or false? True. Um, 46. The set of 3, 0, 9, 6, and 2 is equal to the set of 2, 9, 0, 3, and 6. Is this true? Getting some mixed things. Why or why not?
Because it's not in order.
So they don't have to be in order. I just like them in order because it's easier to grade and it's easier to deal with. And my brain works that way. But they don't have to be in order. But is every number in the one on the left also in the one on the right? Right? And there's no extra numbers in either of them, right? So that means that those are equivalent even though they're not written in the same order. We can order stuff in a set however we want, so this would be true. If the one on the left had a 4 in it, it would not be true. Let's see, one more of these true-false ones. 48. The set of 3, 7, 12, and 14 is equal to the set of 3, 7, 12, 14, and 0. Is this one true or false? False. Why? Yep, there's a 0 in the second one. So this one, they have them ordered the same way, but they gave us a 0. That's extra, so that would be false. Okay, so for these next several problems, what they do is they give you the set name. So they'll give you set A, B, C, and D, and then they'll give you the universal set, and that applies for that entire next section of problems. So I'm going to go ahead and write out all the ones that we would need for what we're about to do, and then, because we don't need all of them for what we're going to do. But so this is for problems 51 through 62. They tell us that set A, well, I'll just write them all, is 2, 4, 6, 8, 10, and 12. Set B is 2, 4, 8, and 10. Set C is 4, 10, and 12. Set D is 2 and 10. And then the universal set, which is going to be everything, is 2, 4, 6, 8, 10, 12, 14. And so then you would use that to answer all the questions about that set of, or about this set of questions. So they'll give us something like 52, and they'll say that C is a subset of U. Oh, these are still true-false questions. So subset, let me find where that is. So it's a sideways C with a line under it, and that means that every element in whatever's on the left also is in the set on the right. So in this case, would C be a subset of U? Is everything that's in C also in U? Yes. So this one would be true. Uh, 56 is B a subset of C? So is everything that's in B also in C? No. So this one would be false. This next one can sometimes be a little tricky. So this little 0 with a line through it represents the empty set. So this says that the empty set is a subset of the empty set. Is this true or false? True? Is that what you think? Anyone else? What do we think? True or false? True. So I have two trues. What do you think?
False.
False? What do you think?
True.
True? All right, so this is true. The empty set doesn't have anything in it, and so it can be a subset of itself. And so this would be true. Let's see. So now, essentially, we're doing what we did with the element of, is determining if something was an element of something. We're doing that, but now we're filling in if it's a subset or not. So 64, we have the set 1, 5, and then a blank, and then the set 0, 1, 2, 3, 5. And we want to know if the set 1, 5 is a subset of the set on the right. So would that be a subset? Yes, because 1 and 5 are in both, or both, wow, words. 1 and 5 are also in the set on the right. So that we would do as a subset. Let's see, 66. The set of 5, 6, 7, 8. And we're determining if this is a subset or not of the set 1, 2, 3, 4, 5, 6, 7. Is this a subset? Nope, because the one on the left has an 8 and the one on the right does not. So this, we would do the same thing, draw a little subset, and then just draw a line through it to show that it is not a subset. Get this focus back in. Okay. All right. Determine whether each statement is true or false. So these are moving into intersection and union problems. So remember, the intersection is where there's overlap. So like if you were to draw a Venn diagram, it would be the elements that are in that middle piece, okay, would be what the intersection is. So they have to be in both things. A union is that they are in any of the spots. It's everything that we have in the whole thing. So 70. And we're determining if this is true or false based on what they tell us. Then we'll do some where we're determining them in a minute. 8, 11, 15 is in a set intersected with the set 8, 11, 19, and 20. And they tell us that when they solve that out, it's equal to the set of 8 and 11. So basically, we're looking to see, are 8 and 11 the only two things that are repeated in both of those sets? Yes, so this one would be true. See, then we have 74. We have the set 6, 8, and 9 intersected, union with the set 9, 8, and 6. And they tell us that that's equal to the set of 8 and 9. Is that true or false? False. Why? Yep, there should also be a 6 with that. All right, so for the rest of the problems, they give us 5 sets that we're looking at to answer the following questions. So I'm going to write all of those out so we can reference them. So they give us, this is for problems 81 through 110. They give us set U is the set 0, 1, 2, all the way out to 13. So it goes all the way out to 13 for the, and that's, again, the universal set. That's everything that the other sets are contained in that set. Set M are 0, 2, 4, 6, and 8. Set N are 1, 3, 5, 7, 9, 11, and 13. Set Q is the set 0, 2, 4, 6, 8, 10, and 12. And then lastly, set R is the set 0, 1, 2, 3, 4. And these problems specifically say to use these sets to define the following, and identify any disjoint sets if there are any. And so just as a reminder, disjoint means that there's no elements in common, essentially meaning that when we put it all together, we would get the empty set out, would be like our answer, in case that happens. So let's do 82. And this one is going to be the intersection of M and U. So M intersect with U. So some people like to rewrite the sets every time. I just think that gets to be a lot to rewrite all of M intersect all of U. So that's also why I write them all out at the beginning, so I can just go back and reference them. So if I did M intersect U, intersect means that anything that is in both, I write it down. So what would my intersecting set be for M and U?
0, 2, 4, 6, 8.
Yep, 0, 2, 4, 6, and 8. Nothing else is in both, so that would be it for that one. How about 88? We have M union Q. So I'm looking at these two. The union means everything that is in either set, and so what would the union of M and Q give me? Zero, 2, 4, 6, 8. What else?
10, 12.
Yep, 10 and 12 would be included in this one as well because it's a union, so it's everything that's in either set. Let's see, 90. The complement of Q. So remember, use our universal set that has everything that we're dealing with in terms of for these set of problems. So if I have the complement of Q, what would that be? What is everything not in Q?
1, 3, 5, 7, 9, 11, 13. All common numbers.
Yep. And then 94, the empty set intersected with Q. So I'm looking for overlap. So is there any overlap with the empty set and set Q? No, right? So this would be equal to the empty set, and this would be one that we would want to say is disjoint, basically meaning there's no elements that are in both. No elements in common. And then the last one that we're going to do, unless y'all have questions or something, is 100. This one is a pretty intense one. It's R union N, and that's in parentheses, intersected with M complement. So this is one where I tend to rewrite stuff, okay, because there's a lot that I'm dealing with, so I'm going to have to do this one kind of in steps. So this will still follow like your PEMDAS rules that you're used to for all the rest of math. And so the first thing I'm going to do is the stuff in parentheses. So I'm going to do the R union N. So what are the elements that are in either or of R and N? Like, ignore this part. What would R union N give me?
1, 2, 3, 4, 5, 7, 9, 11, 13.
Yeah, and 0. So everything that's in both, so 0, 1, 2, 3, 4, 5, 7, 9, 11, and 13. And now I'm intersecting that with M complement. So I need to find the complement of M. And so, again, that's everything not in M that is in the universal set. So what would that be? What numbers are not in M?
What numbers are not in M?
Yeah, that's what complement means. So what numbers are not in here that are up here?
1, 3, 5, 7, 9, 11, 13.
And even after 8. So 1, 3, 5, 7, 9, 10, 11, 12, and 13. So now I can do the intersection of these two things that I have written down. So what numbers are repeated in both of these? Yep. So all the odd numbers happen to be repeated in this one, and that would be your final solution to this one. So the ones like this are obviously going to be the hardest ones because there's multiple steps that you have to do to piece it together. So make sure you pay attention to all of that. Any questions about this? No? Okay. So your problems, and I'm going to tell you this is one of the longer homework assignments you'll have just because there's so much in this section. But it's 13, 15, 23, 35, 37, 43, 55, 73, 81, 87, 89, and 103. So you need to make sure you write those down. But what I'm going to do, since it took up a lot of time to do this section today, normally you would just have like 20 minutes at the end of class to do these. But I don't think you're going to finish this with the few minutes that we have left. And so what I'm going to do is give you time tomorrow to work on these as well. because I normally allow 2 days for this section just because it's got a lot of material to it. And so you'll be able to work on this in class tomorrow. And if you haven't done the notes for the next section, you'll be able to do that tomorrow in class as well. Now, that being said, the notes are due. Technically, I have them due tomorrow because we need them on Thursday. But if you wait and do them in class tomorrow and you don't finish them, you do need to have them done by Thursday. So if you feel like you're not going to be able to do this and the notes tomorrow in class, then you need to make sure you start on it tonight. But it shouldn't be that long, so I don't think it'll be that big of a deal. And you have enough time to you could probably get about a third of these or something done today in class. This first few shouldn't take you too long. It's just the last few that are going to take a while, potentially. Any questions? Okay.
I have
Do we have to do that here, or can I wait till I get home to do it?
Do what?
Is it forced that I have to do it here, or can I do it all at home?
If we have time, you need to do it in class. I won't let you do anything else until I see it, that it's done. That's the whole point of the flipped classroom, that you don't take it home.